Welcome to another series on Introduction to DataFrame. We'll import Pandas library. There is a CSV file NBA. We will access the CSV file and work on that. So the file CSV NBA.csv is stored in the variable NBA. We will see what the NBA file contains. So it is similar to series except that it has multiple columns. Pandas has created a numeric index, a standard one that starts at 0 and counts all the way to the final record. This is not part of the CSV. This is automatically generated by Pandas. But other than that, you see a whole lot of columns, and we can see these columns as series objects that are connected through a common index. Here, NaN stands for null. It is a missing value, and we have a row of empty values, and all the values are missing. Whenever a column has a name and a value in it, even when missing column value, and that column stores the numeric values, those values will be stored as floating points. For example, the age. It is stored as a floating point because it has a NaN in it. Similarly, the weight. It is stored as a floating point because it has an NaN in it, and same is the case applicable to number and salary. The three dots in the middle are known as the eclipse. The last index is 457, which means we have 458 rows because it starts at 0. So the very first index starts at 0. The only difference in this method is data frame has multiple columns, whereas series has a single column. Similarly, when we give NBA tail, we get the last row. In addition to the above, series and pandas has some attributes in common. We'll look at those attributes. The first attribute is index. If you recall the index, it gives the start and end index position. It starts at 0, ends at 458 at a step size of 1. NBA.values is another index, is another attribute which gives the values in an array. NBA.shape, the shape gives a tuple that gives the dimensions of the data frame, that is the number of rows and columns. There are 458 rows and 9 columns. The D types, the output is a series with column names as the index labels and the values are the data types for each column. Object refers to strings in Pandas language. Float 64 refers to decimal points. We can continue to apply attributes and methods to data structures. For example, to count the number of data types in a dataset, we use value underscore counts. So we see that there are 5 objects and 4 data types, 4 variables. which are of float data type. So the value count gives the number of times each unique value appears. There are some attributes and methods which are unique for exclusive for data frame and not for series. Columns. This is an attribute which shows the list of all the columns in the data frame. The columns, the column heading are the index labels, and this is available only in a data frame and not in a series. Axis gives the range index, starting index and the ending index, and it gives a Python list with both the indexes that we have in the data frame. First, we have the range index, which is the array index. Second is the column labels. So, why is this limited to data frame? Because a series does not have multiple rows or multiple axes or columns. The above two attributes are specific to data frame. One more method specific to data frame is .info. No argument needs to be entered. This gives the column index, column labels, column index, column labels, number of non-null values, and data type of each column. It also gives the total amount of space it is taking in your computer's memory. So we will take another data set. Revenue.csv is another data set, and here the index default index is 0 to 9. We'll change the date as index of the data frame. We can see that the index 0 to 9 has been replaced with the date. So what we will do is we will create a series and store in the variable yes. There is a method known as sum which will total the values in the series. Now we will see when we give the sum function to the data frame, we will see how it works. It calculates total for the values in the column. We can also mention axis equal to index. For example, it will give the same result. Or we can give axis equals 0. When we say axis equal to 0, it looks at the columns. If you want to sum total of the rows, then we have to give axis equals 1. So now it sums the total based on the rows. We can give axis equal to columns also. So if you see, it takes the values in each row and totals the respective columns. It will sum up the values for each index label. In this case, dates are the index labels and the values are the sum total of each row. This option is not available in series. If you want to extract a single data column from a data frame, we have the data frame NBA. Assume we want to extract the variable or column name. Pandas provides a series. It is going to keep the index labels from our original data frame and take only the values from the data frame. Double quotes should not be added. Similarly, we can try the above method works only when there are no spaces between the names. If there are spaces, for example, if there is a space between name, first underscore name, or first hyphen name, or a last space name, then this method will not work. In such a case, we have to use another method. Enter the column with name within square brackets and within quotes. In this method, space and special characters are allowed. In this space and special characters are not allowed. The ideal way to store more than one data type is list. For example, NB name and salary will extract both the columns name and salary. And the column, if it are extracting more than one column, then it has to be in the form of a list. The first square bracket is for extracting and the second square bracket is a list. Because we're extracting more than one column, pandas cannot represent this as a series. We can reverse the order of the columns by simply reversing the order in which it is entered. And this gives a new data frame. So all attributes and methods can be applied on this. This is one method. We look at another method to extract the columns. We can store the column names to be extracted in a variable and call that variable. So we want to extract the three columns name, salary, and age. The three columns that we are going to extract, we have saved it in a variable. And when we call the variable with the data frame name, it will extract the values from the three columns. Here you don't have to put square brackets. If you want to add a new column to a data frame, we will see how to do it. In the previous method, we saw that it is possible to extract a single column using a square bracket. If you try a column that does not exist, it will throw an error. For example, Because the column does not exist, it throws an error. Instead, if we add an equal to sign and assign values on the right side, it is going to generate a new column even if it does not exist. We have to be careful because if the value in the quotes within square bracket does exist, then the entire column will be overwritten. The new column is always added at the end, and the value what we have assigned to this new column will be populated to all the rows. There is another method to insert a column, and here the parenthesis will not be required. Let's look at the available parameters in the insert method. The following are the parameters that are available in the insert method. We have LOC, column, and value. These are the three important ones here. So LOC here represents index position within the columns. So we will give, if you want to insert the new column in the fourth position, then we will give so it has inserted a new column and it has inserted in the fourth position 0, 1, 2, 3, and 4, the fourth position. Now we will look at broadcasting operations. Using broadcasting, we can apply operations to the entire series one by one. So let's extract the column salary. Let's say we want to add a certain amount to every single value. There are two methods. Let us look at the first method. So I have manually added 5,000 to all the rows. You can see it has increased by 5,000. The second method is you don't have to use the add function. It works not only for add but every single mathematical model. For example, if you want to express the salary in millions, then it will express the values in millions. If there is a null value, it is going to return NaN. Assuming you don't know the result of the original values and you want to create a new column, then you will assign the result in a variable. For example, so since we have created a variable and the calculation is stored in the variable, it has created a new column and the values are stored in that. Next, look at the value counts method. Value counts is only available on a series or a singular column. It is used to count unique values in a single column or in a series. When I apply value counts on a series, then we get a certain output. Let us see. Here, the team New Orleans Pelicans has 19 players, and the team Orlando Magic has 14 players. Let's see another column. The NBA position seems to have limited values, has limited unique values, PG, SF, SG. So let us see how many values have against each of these, how many observations are there in against each of these values. So there are 102 observations where the value is SG, 100 observations where the value is PF, 92 observations PG, and so on. If you want to see the topmost record, we can give the argument head. We can use this method on any data type. Weight is an integer data type, and we have applied the method on 8. What if you want to drop rows with null values? We can see that the last row has only null values. Of course, these two were created by us. We will call this file again. So we can see that the last rows has only null values. And here we can see that the third row has a null value, only one of the variable. If we give NBA the drop NEA, we see that the third row is eliminated. Also, the last row, which had null values in all the columns, is also eliminated. So, the drop NEA removes the rows which have one or more null values in the data frame. Let's see. This is due to the how parameter in the documentation. Since it has any as the default value, it removes any columns with a null value. The second value that we can give is all. When all the values are null, then only it will remove the row. Otherwise, if there is a single value is null, it will not remove that row. Here, only the last row, which had all the null values, are removed. The third row, which has a single null value, is not removed. If you see, though we have dropped NA, it is not removed permanently. It is only removed temporarily. To ensure that it is saved permanently, we have to give the parameter in place equals true. By default, in place equals false. When we say in place equals true, it will overwrite the existing file. So because we have given in place equals true, now we see that the last row has also eliminated. Assuming we don't want the columns which have null values, then so we can see that the columns college and salary are missing because these two had null values. Here we have the two null values and here there's a null value. There may be more null values in the rows in between. So these two columns have been removed. But these are not removed permanently till we use the in place parameter. We can also give but what if you wanted to remove a specific column? Here we have removed both college and salary. If you wanted salary but we don't want college, then how do we remove it? So here drop in a substitutable college will remove only the null values in the variable column, in the variable college. For example, if you had given salary, it will remove only the null values in this column and it will not remove the entire column. But we see that the college still has null values. If we want to remove the college also with null values, we have to include it in the subset. So null values in both college and salary have been removed. But assuming we want to fill the null values, then there is a method known as fill NA. The fill NA can be applied on data from directly, and in certain situations it will work. In this example, when we gave it fill NA, there were null values in the salary, so it is replaced with 0, and null values in college is also replaced with 0. In the case of salary, it works because it is an integer, but as in the case of college, it is a string value. Replacing values with 0 is not a good idea. So we can apply fill NA on a series instead of entire data frame. This will fill the null values only in the column salary. And if you want to make it permanently, you want to save it permanently, we'll see that it has replaced null values and it has also overwritten the original file. Now only the salary column with the null values is replaced with 0 and other columns are as it is. In the case of string variables, we can replace with a string. For example, the null values in the college fill any details not available, so it will fill the values details not available. And if you want to store it permanently, it will store it permanently. So we can see that the age, salary, weight, or float data types, it has a decimals. So we want to convert this age, weight, and salary into integer data types. Let's see how to do it. This method will not work if the series has null values. So we will replace the null values with a string value, and we have already replaced the null values with 0, so we don't have any null values. Otherwise we have to replace with the null values. So if you want to change the data type, first we should find out what is the data type of the current data set. There are two ways to find the data type of a data set. NB.d types gives the data type for each variable. Another way to find the data type of a data set is .info. We can also find out if there are any null values. Since the total number of rows is 457 and the non-null values is 457 in each variable, there are no null values. Now we can change the data type to integer. The salary is floated data type. We have changed this to integer data type. And the as type does not accept the parameter in place equals true. If we give in place equal to, it will throw an error. So in place equals to need not be given. If you want to change the salary back to float, then so it has again changed to float. To store the values permanently, we have to assign it to a variable. This case type is a data type is not available in Python. It is available only in Pandas. Now we will look at a new data type which is category. The category data type is not available in Python. It is available only in Pandas. Assuming there are million rows with some variables having unique values, we want to find the number of unique values. So the number of unique values is 5, and the data type is position is an object, and the total memory usage is 39.9 KB. We'll change the data type. There's a new data type known as category. We'll change the data type to from object to category. So we see that the data type has been changed to category. Let us try another column. So out of the 457, there are 30 unique values in the column team, and the team is an object data type. We'll convert this into a category. So it has been converted to category, and moreover, the memory usage has also come down. We will look at sort values method. It is used to sort a data frame or a column in a data frame. There are two ways to do the sort method. The first method is you can see that the parameter is looking for the very first parameter is by. That is, it expects the column name based on which it should be sorted. So we will give, so it sorts all the records, all the observations in the alphabetical order of name. If you want to sort it in the descending order, it will sort in the descending order. This does not sort the original dataset until we add the in parameter in place equals true. So one beauty of the sort method is it will place all the null values at the end. Let us call the file again, and then we will see how it works. The null values in the name, we did not have any null values in the name. So if you were to sort the null values by salary, then we will see how it does. All the null values are pushed to the end. To place the null values in the beginning, we have to add the parameter we see that by default any underscore position equals last, which means that if there are any null values in the value in the column that has to be sorted, by default it will be pushed to the end. When we give any position, any underscore position equals first, there are two options. Default is last. If we give it first, then it will place all the null values in the beginning. This is how it will be sorted. And if you store it permanently, so we have the null values in the beginning. There's another method by which it can be sorted. This is not another method, it is just the part 2. It is, if you want to sort more than one column, then how do we do it? First, it sorts alphabetical order, the column name, and then it sorts the alphabetical order, the column team, and then it sorts in alphabetical order, the column name. We can give it the descending order. It will sort the team in the descending order, and then it will sort the name in descending order. If you want to sort the team in ascending order and name in descending order, then it will sort the team in ascending order and name in descending order. The true or false should be in the same order in which we name the columns. The team is first and name is second, so true will be assigned to the team and false will be assigned to the name. To make it permanent, we have to use in place equals true. So this is stored permanently. We can sort with the sort index method. So what we have done is we have sorted based on the three columns. First, it will be sorted based on number, then it will be sorted based on name, and then in based on salary, and we have stored it permanently. We see that the index is not in order, and assuming we have saved it permanently, since in place equals to, it has saved it permanently. If you want to reset the order to the original one, then the original index will be sorted based on the original index. If you want to sort based on the descending order of index, we can give ascending equals false. It should sort based on the descending. Thank you.